This week's Fix It Friday is a kind of practical based question looking at testing for halide ions, in particular testing for aqueous chloride ions. But this is also a two-part question because it asks you how you would confirm that no other halide ions are present. So how many marks do you think this answer got? Because it looks, if we read it really quickly, to be relatively convincing. Well, this question actually only scored 1 out of 4 marks. So let's go through, see where it went wrong, see where we can improve the language, and just generally improve on this question. So, adding silver nitrate is correct. However, this student has then said to add hydrochloric acid, which contains chloride ions, and rather takes away from the fact that chloride ions is the thing that you're trying to test for. So if you are going to add an acid, which actually all our ions tests for anions, for negative ions, do involve adding an acid usually, then you need to match the acid to the reagent you're using. So if you are using silver nitrate, you need to be adding nitric acid. You would use hydrochloric acid with barium chloride, for example. And so that's why we can't use hydrochloric acid. Actually, if you had not mentioned the acid in this question, you would have got away with it. You also got away with just writing silver nitrate in this question, but I would always recommend that you're very clear that you add a solution. So when you're testing for a precipitate, the last thing you want to add is a solid because you're testing for the appearance of a solid, so you're always mixing solutions together, or you could simply write AQ. Then we've got actually the 1 mark that was achieved in this question, which was for saying a white precipitate. So that does actually get us the mark. Make sure that you always include the word precipitate and don't simply give a colour change if precipitate is the observation. Not so easy to spot, but there is a mistake in the ionic equation in that the silver does not have the charge. Now this question again was quite generous and did not ask for state symbols in the ionic equation, but usually for precipitation we would want to make sure that we are writing our ions that we start with as aqueous and our final precipitate as a solid. So far we've got a mark for what we're adding, silver nitrate, preferably solution with nitric acid solution, a mark for our observation, which is a white precipitate for silver chloride, and a mark for our state symbol, preferably with, for our ionic equation, preferably with state symbols. And the last bit, so the last mark in this question is for confirming that no other halide ions are present. And it says you will not see any other precipitate, which is proof there are no other ions present. Well, not really, because the precipitates could kind of be like difficult to see. So what they were really looking for is this extra part at A level with the halide ions, which is their solubility in ammonia. So if I was definitely sure that the ions that were present were chloride, I would want to maybe add dilute, and again aqueous, so be sure on your states it's normally aqueous, ammonia. See what you would see, silver chloride will redissolve and there will be no precipitate left. So you can say that because if there was any silver bromide is cream, and if there was just a small amount of silver bromide formed, you might not see it like with a larger amount of white silver chloride made. However, if you added that aqueous dilute ammonia and there was still some precipitate left after you'd added a reasonable amount, then you could infer that maybe you had some silver bromide, and you could test that by adding your concentrated ammonia solution, and that would dissolve your silver bromide precipitate. Silver iodide will not dissolve in any concentration of ammonia. That's our trend down the group. There are other ways that you could also say there are no other halide ions present, and that's using displacement. So if you had bromide or iodide in the solution and you added aqueous chlorine, then you would see either the orange of the bromine or the brown of the iodine. You would see a colour change from a displacement reaction. So displacement reactions can also be tests for halide ions.